Hello guys, welcome back to another stream. So today I want to take a little bit a detour I would say, into the TCL scripting. Because we not really did that too much in the series. So and I thought of a problem or something which I could solve. And yeah, let's see how this goes. Now, let me get set up here. I will just open a session. Maybe the flange option is not a bad start. The thing I want to do now, or today, I want to do something which could help understand the future releases of the MPC Forces tools. And that is to just have a visualization of the group detection algorithm. Yeah, that sounds maybe a little bit too complex or too, yeah, it's not easy to grasp. So let me get that ready. So basically, once again, what this MPC Forces tools does is per RBE element, it connects or it finds the connector parts. So the blue part is one part and the black part is another part. This doesn't have to be this simple, right? So it can be a lot more complex. And if that's the case, maybe in the future, no, not maybe. It's very certain that I will need a functionality to see the parts, because I cannot rely on having it already in the model. You see, here you can see with the colors, right? But let's just assume they would be all in the same part. Yeah, but basically I think there's even a better way to show that. Here it's very simple, right? So here you can have you already have it um into two different components. But what if that's not the case? Didn't I download the thing here? Let me just quickly check the step file, because then I could show that also on a little bit more complex data. But I unfortunately I think I will not be able to do this. Yeah, doesn't matter. So let's just think about this part. Yeah. So in the Model Explorer we have the two components, but it's not clear that we would have two components. I'm not sure if I want to do this with this model. It's a little bit too simple to show it. Well, for sure I could just duplicate it. I mean, that would make sense, right? Yeah, for this exercise, I think this will make sense. Yeah, let's do just the following. We have this model and it's not that big, so I think we can use this model. First, I will just move all the elements into one component. That's done with the organize thing, which you can find under assembly. So I can say that I want to have all my elements into destination one. So that would be the component one. So everything is blue here. The second component we don't need. And now I will just duplicate components. Yeah, so I will just take this, copy that, paste that. And that didn't work. Copy it, paste it. Yeah, so now that did work. And I will move that thing that we can also see that we have two of them now. And now maybe I will just, well, the SPCs will not get moved, right? That's a little bit of a pity. So the forces are not being moved. Yeah, okay, that doesn't matter. We will make something out of that. Okay, so again, we will just duplicate that. Copy, paste. Doesn't work. Paste. Okay, and also move that up so we can see that. So just to have a little bit of a more realistic model, right? So now we have four of them. just to be sure, the only thing which is not really working for here is the load collectors. So let's just fix that. So SPCs is the current load collector, so I could go into analysis and then on the constraints and then just do a bunch of others. So I'm not really caring that much about if it's accurate or not. So we can make that by phase. By phase. So I would like to have this one and this one. And I just, oh, and still another one. So everything is holding placed on those ones. Yeah. And maybe now we can also play around with the loads a little bit, because now we have 4 models, so that we have a little bit of a different result. So this maybe I would like to do 1000 newtons in the Z direction. Yeah, why not? Then, that was not good. Let's control Z out of that, because we have to go into this one. Yeah, you can see that with the colors. That's also one of the reasons why colors are important. Okay, so 1000 Newton here. And what else could we do? Something like a little bit more crazy. Something which is maybe not constant vector, but constant components. And something like a almost 3D vector. Let's do here one more. Oh, I selected here one. Something like that. Okay, so now we have 4 models. And the reason I want to have this model here is the following. I'm just going on organize once more and say I want to organize all the elements to be in destination 1. That means component 1. That means I can delete all of those components because there should be nothing in it. So this is an unsorted model. Yeah. So that means nothing is really taken into components. And I think it's good to have something which can visualize the different connected parts, because I realized that part of the tool is a tool of itself, because the tool wants to have the connected parts for NPCs, and for that I have this graph and I just make group detection for the complete thing. But this itself, I would say, has some valid load cases, use cases. Yeah, that means just think of it maybe that you have a complicated model, it's meshed, it's all in one component, and you want to have that split into separate components. That could be a use case. And this is all hidden, or maybe not really hidden, but it's a functionality of the part, which makes a lot of sense to make use of. So this is what I'm planning to do. And therefore I will do a little bit something of TCL scripting. So TCL scripting, I think in this case will be rather straightforward. The thing I would need is I would need to create a new collector, so a new component. I would need to move elements from one component to the other. And that's about it. So I think that the TCL script by itself will be rather simple. Now, in order to see how this is being done, you can look into the file. So I think there's also now in this thing something like a direct way of going into it. Is it command file? No. Let me quickly get that for you. So basically that's in the documents folder, and there's a file called commands TLC or TCL, commands TCL. And for sure I have to take the most recent one, which is nowhere to be found because I'm using a session which has its origin I'm not really sure, to be honest. That should be in the flange model. So I think I can look directly there. Let me just quickly see if it's true. So data models. Do we have something like a commands TCL here? No. But to be honest, it should be this directory. If I do load and CMF, it should be this one. Yeah, CMF, there it is. I'm not sure if this is really what I was looking for. Because that's not really being done here with every command, right? Wait a second. So let's see where I can find this. So it depends on where you start your Hypermesh instance from. So if I do, for example, load script, it will also go here, but there's nothing here. So the CMF file, where is that? It's not there. I thought it would be there. There is a CMF file, but this is not really. Okay, forget about it. So for today, I will not use that. So basically, what we can do with the TCL console is we can do stuff like this, what we are doing in the GUI, and do that with code. So the command which I have looked up in another program is like create mark elements and then one, and then you have the element IDs. So for example, if I would do something like this, yeah, so this would create a mark on two elements. Now I would have to know the IDs of those elements. So for example, this would be 34193. Let me just quickly get that. 34193, and the other one would be 41795. 41795. So basically, if I would like that command create mark, and then elements, 1, and then the IDs. So just that you are here in the clear picture. So I'm looking up a script which I did very long time ago, but still valid. And this is more or less the thing we want to implement here today. So create mark elements, and then 1 is a temporary ID. So there could be, for certain commands, you need more than one mark. And so there's a possibility to have more than one mark. But we will be using just one mark, right? So this is that. One mark, and then those are the two element IDs, right? And now if we have shown that already here, maybe we can have something a little bit more complete, that you can see or understand what I mean here. So basically this, okay, this command here, we have just been replacing by our own IDs. And now here create entity comps name, and now we have a name. Let's just say this would be part 1. And then we have the move mark elements 2, and here's the name. There's also a method where you can get the ID by name, and I think it's very important for a little bit of more proper TCL scripting. But this is all we would need for something like our visualizer. Yeah. So basically, let's just execute this code and see what it does. Oh, it does not work. What? Move elements part. Oh yeah, that does not work because we would have to name that part 1. But it also did not create a collector. Strange. TCL error. A component by that name already exists. All right. Yeah, so this got me good. Let's do the same thing with part 2 because the part 1 is already taken. Okay, see now that I have not selected the elements anymore. The elements are now in this component, right? So that's pretty cool. Okay, so I will do the following. I will let this model be run in the background, and during we wait for the thing to finish, we will do the Visual Studio Code stuff and have something being outputted to our text file, which resembles a script, a TCL script, which can then visualize all the recognized parts. Yeah. So this is what I want to do now. Okay, so let's do this. Yeah, first of all, I will just revert the things I did here, right? Control Z works, and now we can delete the part 2. So that makes sense. And now I can run this. So analyze. There's still just one load step, so nothing to change for me in the output section. So I can go on analyze and then just go data models. That's good. And let's just call that 4x4 and let it run. It should not take this much time. I'm more fearing that there would be something which I did not plan to have, or some error which I'm unaware of that could happen. By the way, drinking some tea today again. Nothing, not a green tea today for once, but just some regular fruit tea. Yeah. All right, so it's running. Seems good. Let me also save that model because I think I will use this model maybe in the future. 4x4. Okay, now let's go to the TCL, and the TCL code should be TCL the Visual Studio Code. That should be rather straightforward, I think. Let me just quickly close all the documentation and stuff like that and see where we can put this. Yes. Okay, so we have the main method and we have the force extractor method. So this MPC forces extractor could now also have a little bit of variables. And yeah, I think we should do that. So basically, first of all, we now know what kind of things we want to have in our code, right? So this would be this. But if you think about it, what should we have? We should have maybe something like a part ID. We should definitely have all the element IDs. And that's maybe also a little bit of a problem. That's definitely a problem. Because we have nodes in our script. And elements is a different story. But I think we can use that, or we can handle that. Let's just go and look what we have to find. But yeah, just that you know, so we need the elements, we need the part ID, and that's that, I would say. Okay, where should we do that? In which package? It's not a reader, it's not data structure. It's maybe like a, is it a writer? Or is it a TCL? Yeah, let's just call a package called TCL. Is it good? I'm not sure here, to be honest. TCL sounds like a bad package name. Let's do visualize. Visualize, and then let's do a new file, TCL visualize. And yeah, for sure that should have a Python extension. And yeah, now let's do here a class called visualizer connected parts. Something like this. That doesn't make any sense. So what should the init look like? What do we need here? We would need something like a part ID to connected node IDs. That makes a lot of sense. Then also there would be a good thing to have something like a node to element ID or something like that. No, yeah, but the problem is now the same node is being used by multiple elements. Yeah, that's a little bit of a, it's tricky. It's tricky. Maybe we have another method which translates the nodes into elements first. That would make sense. But it's also a little bit more of a, yeah, code which doesn't really do much, but you might still need anyway. I think let's just put that aside for a moment and let's just look into the elements, how that is. So the node has a connected elements list. Well, basically, I think that's it. We could use that. I mean, running times. Talking about running times is not that good, but thinking of a simple way, this is it. Let's just check the element. The element has also the connected nodes. Yeah, basically. Well, you think that if you have connected nodes, you would assume, or I think you can safely assume, that all the nodes are in the same part. Part meaning the connected groups. Because the connected groups are connected groups which share element links. And if two nodes would share an element links between two parts, then the two parts would become one part. Yeah. So you could safely assume that. So there would be a safer or a simpler way of doing that. But I'm just now thinking about what's the better way. Just think of it. What's the first thing you have? You have the list of connected parts, or maybe it's a dictionary which has an ID too. But there's a list of connected nodes. You could now go. Yeah, you could go to every node and then check the element and just make a translation from node. Yeah, I think we have to do that. To be honest, I think we have to do that. So excuse me. We have to do the following. We have to translate nodes to elements. That we have a list of connected nodes, that's good and fine, but for this, what we have to do now is we have to have a list of connected elements. Which is easy to get, but I'm always always worrying a little bit about running time, because if you have multiple millions of nodes and multiple millions of elements, you should be very cautious not to do something like a for every node, for every element in the node, check if it's in the all the nodes but in my list. If you do something like that, running time will not be so great. So I'm a little bit cautious of my steps here to just try to get an efficient solution first, right? So that's why it's taking me a little bit more time. So the part ID to connected node IDs is the dictionary to go into, and I think with the elements or the nodes, I think we can translate that to a connected elements list. The forces I don't care about at all. Then let's do something that this has. Well, we don't need it here, but this has definitely a variable called part ID to connected element IDs, because that's what we need. So basically, we would need something like let's just do this thing first. Why is it doubly? No. Okay, let's do the imports. Just need to dict for now. All right, so let's transform nodes to elements. Yeah, and this should definitely give back also a dictionary. So this is one we have to do. Yeah, let's leave it on pass right now. And then, yes, the visualize connected parts. more or less should give back a list of strings, because that is basically the method which does our TCL code. For visualizing the connected parts in Hypermesh. Okay. And that also has a, wait a second, we have to do the list here. That has also something which is an input. That would be element ID to, no, wait a second, part ID to connected element IDs. Right? So let's think about this again. Let's think about it again if that makes sense. Maybe we would not like to have this as something which gives back a list. No, I think we don't like that. Let's return nothing here, but just let's also rename that. Output TCL lines for part visual with. Yeah, so that makes a lot more sense. I think we should give a path here where to put that file. Yeah, so this is a dict, and then we should have an output path, which is string. And we can figure out that one here, but we should definitely have something like an output folder. Okay, so here we should say something like make sure output folder exists. If yes, delete the content. Yeah, you know the drill. Okay, we want to have something like import OS here. What is this? This file, then OS unlink. What does unlink do? I've never used that method, I think. I don't trust this. Unlink? Come on. Is there not a delete? I'm a little bit scared to use this. Wait a second. Let's check in the main. For sure I have done something here too. Oh, turns out I have done it this way. Okay. Forget about it. Let's use it like this. Unlink. So OS unlink. I still would like to have something, a little bit of a description here, but unlink. I'm not sure what it is doing. Some homework to do. All right, so here it's cleaning up. It creates the output folder if it does not exist, otherwise deletes the content. Yeah, that makes sense. With an exception, it prints something. Yeah, I don't care about this too much. Now, whoa. Yes, this is definitely important. I almost forgot it. Okay, now we have this. So we assign now part ID to connected node IDs initially to this as an instance variable. Then we make sure for this, then we should do something like we should do nothing. To be honest, I'm not a fan of putting everything in the init. That should be it. Nothing more. Then we have to transform nodes to element IDs. This is now a thing which we have to do and think about a little bit about it. What's the best way? So basically, I would not like to go more than once over every node. Yeah. Okay. So let's loop over every part ID. Yeah. For part ID, connected node IDs in this items. Yeah. So connected elements IDs is an empty list. Then for node ID and connected node IDs, so this is the node. Node equals node ID and then node whatever this is. You get the node here. Yeah, okay, that makes sense. That makes sense. Then you say get connected elements plus equals node connected elements. Yeah, that makes also sense. But then I also like to have something which is not a duplicate. So let's do that as a set, but I think then this will not work. To be honest, I'm not liking this one bit. Let's leave it as a list. Let's do the sorting afterwards. So for this one is after here. We could also just leave it like this. To be honest, we could just leave it like this, but it's not good practice. Because having duplicate element IDs there just makes it more difficult. So basically from here on now on, I have a list connected element IDs and I would like to remove all duplicates, yeah. So that's typically done with the set, but I'm not sure really if a simple set would work. Koi pilot, don't leave me hanging here. Yeah, I'm not sure if this does it. Built in mutable sequence. If no arguments is given, the constructor creates an empty list. Yeah, this is just a list, to be honest. Why should you sort that? That doesn't make any sense. So wait a second, I have to Google this one. So remove duplicates from integer list Python. So I think there should be something like the set method, yeah. This is the most popular way, using the set method. List comprehension. List comprehension I like even more, to be honest. Yeah, I like it. I like it. Yeah. Or could you just do... Wait a second. I think it's easier to do just for element and connected elements. If element ID not in connected element IDs, then add it here. And so we don't have duplicates. Linter will complain about this to having too many levels and so maybe have to think about something here, but to be honest, my inner senses are crazy right now for this one. So just think about it. You're looping over every node and then you're looping over every element of every node, which is really not good. You could do it also the other way around, but this, to be honest, I think is even worse. If you do it the other way around, you loop over every element and then you check if one of the nodes is in part. So you would then go and check all the nodes every time. And this is horrible. Just think of you going through every node and then you're going through every element, because in order to have to say what group it is in, you have to check all the groups. And so basically you have to check all the elements. So it would be better to have the grouping done first, yeah? So you checked all the nodes and then you just go over all the elements once. One is n by times n more or less, and the other one is 2n. Yeah, so I think this is the better way, but we will see if the running time is a problem. 100% there's a little bit more clever, definitely a more clever idea, which we could use and have the running time optimized. But for now, I'm just working on having it in a way that it is possible to run then. All right, so after that, we could also say that first of all, we should need a part ID to connect it. Self part ID connected element IDs is nothing. Yeah, that's not a bad idea to put that into the variable here, because then we can also leave that here, which does make it a little bit more pretty. And this also removes duplicates. Yeah, why not this in the first way? Yeah, to be honest, I'm not sure if that's the better way. We could do a little bit of a running time comparison. So basically, this one, if you have this one, you could also skip this one. And to be honest, I think I'm doing that. I don't want to check if it's in the connected element IDs. Because just think at the beginning, it's maybe not that much of a big of a deal. But if you are later in time, you will have a pretty large list, and checking that, yeah, I think that's not a good idea. That's definitely not a good idea. We make it like this. I think this is fine. We adding that all to a giant list, and then this giant list is being put into a set. I think if this is any good, this will not have a running time of factor n times whatever. Because what they can do is sorting, and if they have it sorted, the removing of duplicates would be easier. Or even there's something like a copy and whatever. I'm not sure how this is done, but I think this betting on my code is definitely the worst option if I could bet on list set from an efficiency standpoint. So this is basic Python, and I think they have nailed it. Okay. So this returns nothing anymore because we can save that into the self part ID to connect the node IDs. That's good. And so on this point yeah, we have now everything we need. So commands is an empty list. I'm not sure what this should be. Let's give Copilot a little bit of a help. So for part ID and then connected element IDs, that makes sense. Insef blah 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 items, that makes sense. Commands append create entity comps now part and then the part ID, that makes sense. Then append create mark elements 1 and then empty string, no, space join and then string I for I in connected element IDs, that makes also sense. And then move mark element. Yeah, perfect. See, by giving Copilot a little bit of a help with specifying the syntax, that is a great option. Then. Yeah, okay, let's also do a little bit here. For now, it's just default stuff. Okay, we have the output folder, and then we should have something like the output file. But here, yeah, I don't know right now. Okay, let's not think about this for now. Let's jump into the false extract and see where we have something like get part ID to node IDs graph. This is being done somewhere here. So it's not even saved. Part ID to connected node IDs. It's not even saved. That's not a good thing. So let's do something different. Let's do it like this, self. And then we have a self here. Because then I can also have that. And here in the, there's something like a write output, yeah? Here. Yeah, the more we do here, the more it gets obvious that we should have a output creator logger class. Not today. But not today. So this is get NPC forces is not what we're looking for. So get write summary. That makes sense. So we have that. Wait a second. Okay, it's a summary here. Okay, so basically we could do something like here and write the connected parts visualizer. I don't like it. To be honest, no. Let's not do this as write summaries. Let's do our very own method. Write TCL with lines. And then also, what should we have here? A self, and we should also have a output path. And then maybe something like a method description. Yeah, whatever. And now we have this beautiful class called no. All bullshit. So how did we call that? Visualizer connected parts. Okay. Let's visualize the connected parts. For sure, this net needs an import. Okay, so we have that. We given the self part ID to connected node IDs, perfect. And then the output folder. And then what? Transform node to elements. No, we don't do that. Not now. We do it here. But why do we do that? Why do we need to do this? To be honest, no. Let's do this as a private method. Why not? And then let's do something like here. Let's transform the things in elements. And that's if it has not, if it has part ID to connect to them. Yeah, if it is has not, yeah. Correct, because it's not there. Oh, the linter will hate me, I think. Okay, but otherwise we can say if it's none, right? So then we execute this method and then we do the commands and then we did forget to write it to the command. Yeah, okay, that should work. So basically in the force extractor we can just say like this. And let's also skip that. We just say this is the output folder. It's the same output folder? Maybe not. Let's do something like output. There's a better way to do this. Okay, so here should be the output with. Yeah. And to be honest, I don't think even that we should use this. Let's do output path. Yeah. Okay, something like this. Now, this method has to be used somewhere where we also do the summary. Is this maybe done in the main? I think so. This is done in the main. So we could do something like, yeah. Yeah, right. Okay, so let's try and test this on a simple model. What's the model we're using right now? Something like this. Perfect. Let's just run this. Maybe let's do a one little linter check because I think it will just punch me in the face. And rightfully so. Okay, that's not that bad. So attribute blah 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 defined outside from init. Yeah, okay, I get that. Yes. So there should be something like a self dot blah 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 dict empty dictionary. That makes sense. And here it has no visualize. What? Yeah, it's this thing. And then this has no. I'm not sure why. Okay, let's check it again. And by the way, if there's any questions, yeah, questions are welcome. Maybe I have to chat that and put that into the chats because people coming here and going, and but if there's anything you would like to know or so, just ask. So linting is good now. That's awesome. And let's just test it. So task run. Then let's see how it goes. Let's see how it goes. So basically, what's the model file? So plate simple rigid 3D bolt. So data output plate simple rigid 3D bolt. Has no TCL and has no commands. Oh, that was not correct. So it did create part 1. Let's see if we have another part. We have also part 2. Part 1 and part 2. So this makes sense. But the element is not really. No. The element is not what we expected it to be. And this is in the. This should be in the. Yeah, it's not visible from here. It should be here. Something like this. So connected elements. An element has an ID, hopefully. So the element, where is my element? Here, element. Element has an ID. Okay, so that makes sense. Okay, let's just try it again. Okay. That seems a little bit better, huh? Okay. I think we have something now. Should we test it with the flange model? Because I think it's just the best to do it just on there. Yeah. Should we? Should we? I think we should. Okay, so check the model. So we have the flange 4x4. We would need this thing and this thing. Copy and just paste it into the input. And now change the main to use this model. So it would be that one. Flange 4x4. Now it gets interesting. If that works, that would be pretty awesome. Okay, task run. This would take a little bit more time. Roughly, I would say, what was it? Like 30 to 40 seconds or so? Oh, 12 seconds to read it in. I think the other things should be not that big. Now we see that could be now the visualization, but still, it's okay. It's okay. I would say if the thing which is now coming out of that code is correct, then I think the running time is more than good. Now let's see, what can we do now? So data output flange 4x4 TCL visualizations. If I just copy that code, oh no, what did I do? That's if I'm too excited about what's now. Okay, copy all of that, just going into here and just blindly pasting it in. Oh, how long does it take? I think it's quite some lines. The file has been saved. Huh. Did not work. So create entity comms part 1. That should definitely work. And then we have the lines for... Wait a second. Let me quickly paste that into a notepad that we can see what it is doing. So this is that. So we have 8 parts. Why did it not work? Okay, we'll try that again. It says... Oh, okay, I see. It's failing because part 1 already exists. So let's just name that comp and let's try again. Basically, why did the other ones not work? Basically, what I'm thinking it should do, it does not do. A component with that name already exists in the model. Ah, okay. Yes. Yes. Fucking yes. Sorry for swearing. Let me just quickly get rid of the geometry. But it's not really working, or is it? Wait a second. What the hell is happening here? It's not having all parts here. Ooh, that could be now a debugging step. Wait a second. If I'm just... That's interesting. That's definitely interesting. I would not have guessed that. So it seems to me that our method either did not work. Ooh, that's bad. If it really is like that, that's bad. Let's check that. So those would be the elements for... Yeah, that's not that much, right? Wait a second. Let me just... Yeah, well, yeah. Let me just quickly get this right. Let's organize all elements again into destination 1. All back to start. All back to start. And now let's just select the elements by ID. And I'm pasting just that stuff in. Because there could also be something like a maximum line length or so. Oh, this takes a while, huh? So I'm now doing this manually, what I did with the code before. Do we now have the element selected? No, we don't. Okay, let's do that once more. So by ID, pasting that in. Takes a little bit. And now pressing OK. And now don't do anything else. Okay, it doesn't work. Interesting. Huh? Interesting. So there's some flaw here. There's some flaw, I think, in the connected elements. Something here does not add up. So connected element IDs is element ID for element in node connected elements. I think the nodes should be complete. But I'm not sure, or not so much sure about the element and the connected, the nodes and the connected elements. Because how is this done already? This is done in the reader. This is done in the model reader. Whenever I'm creating an element here, I'm giving this nodes. And this nodes is node ID for node, as a node in, yeah, so those are the node IDs. No, basically those are the nodes. Now, node IDs is line content 3 in the following. And if it's if we're not at the end of the file, and if the line starts with plus, then we have more node IDs. Plus equals split line 2. Yeah, that makes all sense. So I'm not sure if that really is a problem now. But there seems to be a problem. Either way, we can test it on a smaller model. Maybe if that's helping. I'm not sure if there is a line limit. That could be it. That could be it. But I would say that's maybe a 10% chance. Okay. Basically, what we need to do. Let's change for an easier model. Let's close all. Let's go to the main. I would like to stay on the flange. So let's do this. And when I'm doing the visualizing, I would say I want to have a print statement here. Part ID and print something like this. And then let's do this. Because here I think I have now a good debugging capability. Now let's run this one and let's open the flange model. Oh, I did not meant to save that. But doesn't matter. It's just like never happened, nothing happened. Okay, so just a flange. It should have two parts, right? And now how many elements should there be per part? There should be roughly 24k elements per part. And there should be roughly 28k nodes per part. Well, I'm not sure what now. Huh. Okay, I cannot run it. I think, oh, okay. That's still something which I did not do. The launch JSON now does launch the main. And it's called MPC. What's it called? MPC forces extractor, so. Okay. So 24 and 28k. Let's see if we have those. I'm not sure if we have. Oh, interesting. Ah, okay, this is before the removing of the duplicates. But the 28 makes sense. That makes sense. But let's do this again. Let's do this again. And let's do the length. Well, it's after it? What? 192k elements? You gotta be kidding me. Okay, forget about this list set thing. I'm not sure if it does remove duplicates after all. Let's do it like this, and let's revert to the worst strategy, but maybe the better one, which works. Element ID for element in nodes connected elements if element ID not in connected element IDs. That's not bad. The problem now with the bigger models is that you have to wait a little bit more for the thing to finish. So where is there a problem here? Okay, it's not there anymore. All right. Okay. Oh. See what I was talking about? The running time. Ah, yeah. Yeah. It's really not good. Maybe I have to do another round with the graph, to be honest. Because why not do a connected graph and connected nodes like this? Maybe also the neighbor thing could help you. Well, it's not that bad, but it's bad. Let's now see if the TCL code now does what we want to do. Because then I think really it's a line issue or so. But now I think it makes sense, right? So 2016 for part ID 1. So 20,000. Let's just make this one more time. Elements. If I just select those. Ah, it's more. It's 24K. Ooh, okay, I see. Okay, there is a problem. But still, I would like to try it out. I would like to try it out. So data output flanged and the TCL visualization, the command TCL, I'm copying that. Let's also rename that we don't have a problem. So those are the initial components. And now let's paste in the TCL codes. Okay. That's interesting, huh? That's interesting. Now, let me quickly run through here and see if I can find where this is being done. So element will be created here. And the element is self nodes. And then for node in nodes, node add element self. Maybe we have a problem also here, but that would be pretty bad. No, I don't think we have that. Let me just quickly see that. So the length of connected node IDs is not the same, but we should be able to see that. So I will organize everything back into, or no, let's not do that. Let's just open the flange again. Let's go to one of the flanges, or one of the parts, and let's select all the nodes there are. So I'm not sure how it is calculated here, but the elements are now in one. So this should be the one with the higher node count. And we have 28,476. Oh, okay, we are missing 300 nodes. Huh. Okay. Good that we have done something like this. Because otherwise I would not have caught this error. We're missing some nodes, but those are not the nodes which are connected to the... Ah, okay, wait a second. We have to delete or deselect all the slave nodes here. Because they are not there. And but still, it's not working out. Let's just make the check for the other part. $28,145. Well, that could be it. So if there's a master node still here somewhere, so yeah, exactly, there is one here. So for part 2, it worked perfectly. Right? So if I just check that, 28144. 28144. And here, there's many nodes missing. 28184. That's just 40 nodes more. But if we do the following, we get that, and we just say we just want to have with the mask browser. Yeah, we have that already. Just the 3D elements. And then let's select the nodes again. Yeah, okay, it works. That's still a master node somewhere, right? Yeah, this one. Yeah. Okay, okay. So that worked. But what? Where are those? Wait a second. Is it really those? Um, maybe, yeah. So this is roughly 300. Yeah, maybe that's it. Okay, nodes. I think that's okay. So let's just assume the nodes are correct. Then I think the problem is still in our visualization code, where we say for each node in the connected node IDs, could there be something which I'm missing? Is there something which I could be missing? So for every node, maybe the element IDs are not working correctly. There's so many ways of how this could go wrong. Let's maybe something like this. I also want to see it, to be honest. I would see if there's something going wrong here. Maybe node elements linkages are not really done correctly. The problem is that the possibilities are endless. What's now? Okay, so all elements is 48986. Let's just get all the elements, the 3D elements for all components. And let's check how many elements we have. 48900. 48986. So that's basically good. Now let's just go to one particular element. Yeah. And then the nodes. It has 10 nodes. What? That cannot be, can it? Oh, I'm hating that. Can I put that simply to watch? I'd like to make that a little bit bigger. Okay, so let's go to the first element. Then it has the neighbors here. No, the nodes here. So this one has 10 nodes. But I'm sure there's being duplicates here. Yeah, you have two yeah, you have duplicates. Okay, so this is the first thing I would like to make to get rid of. Why do we have duplicates in the nodes? So this is being done, I think, in the initialization of the element. Entities, yeah. So we have the. Why should we have 10 elements? Why should we have 10 elements? Isn't it like there's too much? Hmm? There's nothing like a, it's not a first or second order issue, that's for sure. So this is basically it, right? So we have 1, 2. Ah, we have pentas too. 1, 2, 3, 4, 5, 6 nodes. But for the hexa, 1, 2, 3, 4, 5, 6, 7, 8. Okay, we have to really debug this one. Let's go deep inside the initialization of the element. Let's check exactly what's happening here. So let's run it and make a breakpoint here and see what the nodes thing here is. So there's the problem already. Okay, let's forget that. All right, so this is not a breakpoint we would be interested in. It's in a model reader. So basically here, let's make a breakpoint here and see what it is doing here. The node ID seems to have more than it should have. What the hell? I think either I'm completely stupid now, or there's something wrong here. But do we have duplicates? Wait a second. Do we have duplicates? Yeah, we have duplicates. Yeah. So that's the first thing. The last two ones are being repeated. Why the hell? So the problem seems to be here. Why the line starts with plus? So it does this once, then it should stop. Okay, I want to see that. Here, let's do a breakpoint. Let's go to... What the hell? This is not CB. It should be here. Oh, okay. Okay, now we're here. So the nodes ID initially is line content 3 to the end, so 6 lines. Now, if I is not at the end of the file, so that makes sense. Now we have line 2. That should be the next line and continue has those two things. Yeah, okay. So it starts with a plus. That makes sense. Line content now is split. Then we say we make a plus. And now we should have the desired 8s. 8s. The desired 8 nodes. And now I plus equals 1. We're going to the next line and say, there it is. Why the hell are we doing the I plus 1 here? Why? That's so stupid. Let's okay, I plus equals 1 here. Then we have that. Because I don't see why we should have that any different. Yeah, I can be I plus equals 1. There's nothing with I in here. Yeah, okay. Then we do that again. Okay, so this will now remove the duplicates. Okay, and we can remove those breakpoints and go to the breakpoint where we have the problem. Well, just to be sure, let's check if it's really the case. Okay, how long is the nodes? 8 nodes. Yes. Okay, let's continue. This will not solve it, but it's an ugly thing you have to have. So, So that should be still the same. Yeah, still the same. But what should we now look for? Hmm. We're starting with an empty list, and then we are plus equaling every element ID for element in node connected elements. So maybe this node connected elements. Let's see. So basically there's now a node here, and the connected node IDs should have those yeah, this is basically all there is from one part. That makes sense. Now we have the node as an instance. This node now should have connected elements to it. This node? Connected elements. How many elements should there be? 4. So that would be a node on the surface, right? More or less. Because internally it could have a lot more. And now the connected element IDs, I'm a little bit... Huh? Wait a second, how is this? There's nothing, no new statement. I would like to have... Yeah, I would like to have that. I'm still not sure if we should do that. From running runtime perspective, it's stupid. That would be a lot better. So let's just quickly forget for the duplicates for once and just run that again. Let's stop here, and I want to see what the element ID for element in node connected elements is. Because there should be at least 4 elements connected to each and every node. Yeah, so why is it looping? Now what is this? 8 elements, so this would be an internal node. And here we have 0. And then we have... Ah. Yeah, I knew that was a problem. The plus equals. Something like that should work better. And now let's try to do this again. I'm still not sure that this would work, but maybe we have a little bit of luck today. We'll not have any breakpoints. Let's just do it. Yeah, we don't have any luck, so I'm still not getting why the hell is it this big? LAN connected element IDs. Where do I print that? Here. I'm also butchering, I think, running time here. Let's try. Why 192k? Let's maybe do a breakpoint. There is something odd here. Unhashable type list. Ah, yeah. Oh, running time. Oh. That hurts. I know it hurts, but for now I'm just desperate to have a working solution. We can improve the running time after that. Okay, what is this now? What's the length? 19,000. Oh, maximum number of items reads. Okay, it's just 19k. But we have more. There's more. 24. There's so much more. Okay, so there's a problem. There is a problem. I cannot tell you what it is. But basically, it could be that the... we're missing the penta elements. That's the problem. That's the problem. That's the problem, right? No. That would be great if we just would be missing the penta elements. But to be honest, we have something like the length of all elements, and that was correct, right? So all elements was correct. Let's do it differently. To be honest, I'm not caring anymore. Let's do it completely differently. There's something wrong here, and I'm not sure where. But I'm just fed up with this right now. So let's do a node ID to part ID. Right, so that could be something. And now let's do just for because the number of nodes in the connected parts. Wait a second, maybe that's the problem all along. Maybe we have too few connected node IDs. But I don't think so. I don't think so. Okay. Let's do for part ID and connected node IDs. For node ID and connected node IDs, node ID to part ID. Node, this is exactly what we need. And now let's simply... I don't like this at all. Now let's do for element and all elements. Normally, because we have all nodes, right? To be honest, I would like to print that, to be sure. So for element and all elements, element point nodes. Is this a node? Yeah. Part ID. Yes. If part ID, there should be always a part ID. If part ID not in self part ID to connected element IDs, then I should go to bed now. I'm switching that to German because my brain is switching off. So if it's not in the dictionary, then I say self part ID to connected element IDs, part IDs is an empty list. Yes, and then always, no matter what I executed here, I would like to do, yeah, append the element ID. And because I'm sure that I'm just doing every element once, I think I can get away with that. But still, if this now works, then there's something seriously wrong with the element creation. And I cannot figure out what it is. The easiest way what could happen now is that the length of the nodes is not the desired node length. So here's 56,328. This is too much, right? This is too much. 56,328. Okay, no, I was mistaken. Yeah, I think that's okay. The other ones are master nodes. Okay, wow. If it works now, I will switch off and go to bed and figure out what the problem is another day. And if it doesn't work, I will do the same. So, data output flange TCL visualization command. What? Wait a second, I cannot go to bed like this. So for all, oh, okay, sorry, here was an indent missing, right? So for every element in all elements, I get this, and then if the part ID is not none, if the part ID is not there, and then I'm adding it. Yeah, okay. So that doesn't count. That's a simple mistake. Okay. Let's see. Output flange TCL visualization, command TCL. Let's copy that. Let's go to here. Let's rename the parts because we don't want to have anything duplicate. And let's also maybe organize all the elements into one component that we have a little bit of something we can be proud of if it works. Not sure. Okay, I pasted it in. No, it doesn't work. And for me, there's no reason where I can see why this is, right? So the easiest way to debug this now is that if the part ID is none, then let's just print something. Node ID nodes, not in node ID to part. That would be the simplest solution, right? Let's just check that. What? Okay. If we have now multiple prints, then we know where the problem is and we can think about... Okay, it's not that. I mean, what the hell could it be? What the hell could it be? Come on, that is stupid. That's so messed up. What the hell? I cannot imagine that. So we know all the elements are the correct size of elements, right? So this should be going in every element. Then we have a nodes 0. And we ask if the part ID is not none. So that means the node ID to part ID, that worked. And we also know the length of the total number of node IDs was the correct one. Yeah? So basically, we then know the part ID to connected element IDs. This is really frustrating. This is a bit frustrating. If that has this, if that has the correct number of elements, then I think we have a problem in the visualization thing here. Something which I would not expected. So, total elements is 489. That is correct. That is correct. That is correct. Come on. That cannot be. That cannot be, man. That cannot be. We are doing this and now for part ID connected element IDs in self part ID. Let's do that I can see that. And if it's working here, the number of connected elements, I mean, huh? I don't get it. To be honest, I'm not getting that. I would have betted that this works. But maybe that's something about late night streams. It's not you're not so fresh anymore. Maybe it's a line issue after all. Maybe it's a line issue after all. Do the command. Mark and move blocks of max 1000 elements. Does this work maybe better? I'm not sure. So, because, I mean, from what I see is that the code should work. Yeah, because the total elements and the assigned elements are correct from the numbers. But if I'm executing the code, not all elements getting transferred, right? So, and this is not a simple geometry, right? So this is still here. Yeah. Okay, so I will now have this as a final test, and I really mean it now, final. Move that back to here. Delete the two components. And now I think I've executed it. Now it should be flange visualization commands. This has now many blocks. Right? And does it now in blocks of 1000 elements. And just by the number of... So either this works or it did not work because it has duplicates. That those are the two options I see. It does not work, so it must have duplicates. Yeah. I am not sure why. Because the number of elements seem to be correct, more or less. This seems odd, those numbers. Just trying to test something if we have duplicates. Yes, we have. See? Oh, yeah. Ah, okay. Yeah, that's not a duplicate, really. But the numbering is a little bit strange. You know what would be funny? If I chose to go to validate and have... There's a thing with duplicate checks, right? Missing property, yeah. But isn't there a thing to check for duplicate element IDs? All right. Either way, I think I have to go now. I will do that tomorrow and see what we're getting. Should be easy, I think, but there is something which is not working. All right. Thank you for being here, and yeah, see you tomorrow. Maybe Sunday. Not sure if I can make it tomorrow.